Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Problem Solving with Trig. One huge thing that you're going to hear in some of your problems is the angle of depression or the angle of elevation. So let's look at the difference between what those are. Okay, so you're sitting there and you're looking straight ahead. Here's your eye, right? In both cases, I'm not an artist, so forgive me, roughly an eyeball. And you're looking straight ahead. Okay, if I tell you to look down or depress, that would be your angle of depression. And so we could create a right triangle with that. If I said elevate your head, you would look up and you create a right triangle. So I want to compare an angle of depression and angle of elevation of the same measure. Okay, and I want to notice something. So we're going to do a 20-degree angle of depression, and then we're going to do a 20-degree angle of elevation. So we're looking up, we're looking out, and we've got to depress by 20 degrees. And here's our triangle. But we're standing right here at the 20-degree corner. Angle of elevation, we're looking out. I'm going to draw it down here. We're looking out, and we look up 20 degrees. And there's our now this is 20, this is 70, this is 90, this is 70, this is 90, this is 20, right? So if this is 20, this is 70, this is 90, this is 20, this is 90, this is 70. Either way, we're standing at the 20-degree corner, right? So if I'm over here looking down 20 degrees, it's the same as if I'm on the ground looking back up at you 20 degrees. So it's really important that no matter what, you're standing at the 20-degree angle. Even if you mess up the triangle, just whatever angle they give you, that's the angle you're standing at. So be careful with that. Keep that in mind. You have to stand at the 20-degree angle. I try to always make sure that I draw it correctly. That way we label all the sides correctly. We don't get mixed up there. But everything's related. And so if you do mess up, the number one mistake is because you've mislabeled it and you've done it like you're in the other perspective. Like you're at the other angle. You're doing the 70 degree, not the 20 degree. So let's say you're on the ground. And you spot someone on a platform. With an angle of elevation of 36 degrees. All right, let's just draw the picture first. That's all I really care about, is being able to draw the picture. So you were here. And there's your line of sight. You had to look up or elevate your head 36 degrees. to see your friend on a platform. Okay, now if I gave you different numbers, like if we knew how tall you were, you know, we could figure out how far above the ground your friend was. Now, I know there's a difference between the edge of the platform versus the top of your friend's head and things like that. So I do get that this is an imperfect example. But once you draw the picture, now we can use our right triangle trigonometry. We can use sine, cosine, tangent. Okay? Now, could we do, they would looking down to see you, so they would be looking out, and they would have an angle of depression? Absolutely. What angle of depression would they have? Well, they'd have to look down just as much as you'd have to look up. So they'd have that 36 degrees. And it has to do with, if we make a rectangle, rectangles have 4 90-degree corners. If this is 36, triangles have 180, right? So 36, there's 40, there's 90. See how these two have to add to 90 as well. So that's where we're getting that. But they're going to have the same angle of depression as you are angle of elevation to look back and forth to each other. So we're talking about how much you'd have to move your head. And that's why they would be moving their head from here down. You'd be moving your head from here up. Kind of a meet in the middle kind of idea, right? So keep in mind that the picture is really going to depend on perspective. Okay. The good news is we can use SOHCAHTOA. So let's just make sure that we can practice using, we can even use law of sines. It's up to you. Okay. So I'm going to draw the picture. And I'm going to kind of describe what's going on here. Okay, so maybe you notice that there's a known altitude right here. Maybe this is like a mountain peak, and maybe there's a bird flying above it, and you want to know how high above it they are. We're going to find TR. But you notice that you had to look up 75 degrees to look at the top of the mountain peak. And you had to look up 79 degrees here. And that would be for the whole thing. So I'm going to call this Y, and I'm going to call this X. And I have a reason for that. But what I notice is that TR is a part of this triangle right up here, which is not a right triangle. So I can either find TH, and then I can find RH and subtract, or I can just find TR. And I would prefer to just find TR, but I have options. So if I'm going to use right triangles, I have to use all of TH, and then I have to use RH, because that would be my two right triangles, and I could compare them. But if I use the green triangle, I can use law of sines, because 61 if the whole thing is 79 degrees and this part is 75, that leaves 4 degrees right here. And at the 75, 90, that would leave this to be 15 degrees because, right? Let's double check my math here. Maybe my morning coffee hasn't kicked in. 15 plus 75 plus 90 is 180. Check. So if this is 15 and these make a linear pair, then that angle right there would have to be 180 minus 15, or 165 degrees. Leaving us with finding that missing angle of 11 degrees. So we know a lot of information about this particular triangle. And so that's why I said that green triangle that I had highlighted is really, really handy, because we know all the angles. It's not 90 degrees, it's not a right triangle, so I have to use love signs. So sine of 165 goes with 61 feet. And since we want to know this, we're going to use the 4. And I'm going to use C because that's opposite of the C. Okay, now we have a proportion. Let's cross product. C times the sine of 165 equals 61 multiplied by the sine of 4. And then we're just going to divide by the sine of 165 degrees. And we get 17.25. And that looks like its feet. So you can use the right triangles there. You can use whatever you need to. I just realized I had a typo in my calculator. Go back and make that correct. It wasn't 64, it was 61. So 16.44. Hopefully if you did that on your own, that's what you got. So I had 4 on the brain this morning apparently. So please keep that in mind, that you can use the right triangles you see. You can use any obtuse or acute triangles that you see. Just use the appropriate rule to go with it. All right, so what if I want to find the area of a triangle? Okay, and it's not a right triangle. It's kind of a big key thing. Find the area. That was a really weird 5. And we'll say meters. How could I possibly find the area? We know area equals 1/2 base times height. And we know the base is 15, but we don't know the height. And that was a problem they ran into, and they're like, but how would I calculate the height? So altitude is always a right angle, and I drew it to where 51 degrees here, so we need the height. The height is opposite of the 51, so great. We know that now we have a right triangle right here. And so we can do SOHCAHTOA with that. And I know that the sine of 51 degrees in that shaded triangle is going to equal the height divided by 9. So to solve for height, I would have 9 times the sine of 51. So I'll come back down here. Forgot to write equals h. I should have done that. Proper notation and all. So we have 1/2 15 times the height, which is 9 sine of 51 degrees. Now let's see if you notice anything here. Do you see how the 15 and the 9 are the two known sides and the 51 is the part connecting them? Yeah. So the area formula for when you have two sides in the included angle is 1/2 BC sine of angle A or 1/2 AC sine of angle B, or 1/2 AB sine of angle C. So notice that we have an A, B, C, A, B, C, A, B, C, no matter what, and all of them. So that's your formula for when you don't have a right triangle and you need to find the area. If it's just any triangle and you don't have that perfect altitude, this is your formula for it. Or you can solve for the altitude every single time and things like that. So formula, yay. If you forget the formula, you can solve for the height and you can still do base times height divided by 2, which is what you've been doing for how many years now? So in our case, the area of this is 1/2, I just put 0.5, multiplied by 15, multiplied by 9, multiplied by the sine of 51. And we have an area of 52.45, or 52.5. Now, I'm going to remind you that when you're covering an area, that would be like covering a floor. And the best way to cover a floor when you're tiling it is with squares, right? So that's why you can think of it as, ooh, I have to have squares, 1 meter by 1 meter squares to cover the floor. So anytime you're doing area, your label is in units squared. If you forget it, then just use law of sines to help you out so you can get the height, or use SOHCAHTOA to get the height, either way. But the height is a very important part of this, and that's all you're going to need for this is, find the area, make sure you draw angle of elevation, angle depression well. As long as your pictures are spot on, you should be a rock star.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.